To start this video, we have already made 1,2,4-trichlorocyclohexane using the molecular model kit, and the red balls represent the chlorines. Now the way we have made the molecule, we have 1R, 2S, 4S trichlorocyclohexane.
Now we will show why the first carbon has an absolute configuration of R. So we know on carbon 1 we have a chlorine, a hydrogen, and 2 other carbon atoms. Based on this, we can say that the hydrogen has a priority of 4, so we will hold the CH bond away from us. Next we will assign the chlorine as 1, and the 2 other carbons will have to be analyzed further. Since this carbon has a chlorine attached to it, it'll have to have a higher priority of 2, and then the other carbon is 3. Now we will go from our 1 chlorine to our 2 carbon to our 3 carbon, and this is clockwise, so it has an absolute configuration of R. The other absolute configurations can be determined in a similar fashion. Next we will show why the second carbon has an absolute configuration of S. We note that the second carbon has a chlorine, a hydrogen, and 2 carbons. Once again, the hydrogen has a priority of 4, so we will hold the carbon-hydrogen bond away from us. Now we can determine that the chlorine has a priority of 1 because it is more electronegative. Since this carbon has a chlorine attached to it, we will assign it a priority of 2, while the other carbon will have a priority of 3. Now if we go from the 1 chlorine to the 2 carbon to the 3 carbon, it is in a counterclockwise direction, therefore the absolute configuration is S.
Now let's determine the absolute configuration of carbon 4. We know that this carbon is attached to a chlorine, a hydrogen, and 2 carbons. Based on this, we can say that the hydrogen has a priority of 4, so we can hold the carbon-hydrogen bond away from us. Next, we can assign the chlorine to have a priority of 1. The 2 carbons will have to be analyzed further. Since the 2 carbons both have 2 hydrogens attached to it, we need to go further down the chain and look at the next carbons. This carbon has a chlorine attached to it, so this carbon has a priority of 2, while this carbon will only have a priority of 3. Now we can go from our 1 chlorine to our 2 carbon to our 3rd other carbon, and this is a counterclockwise motion, so the absolute configuration is S. Since this is a cyclohexane ring, we can perform a ring flip like this. These 2 molecules are ring flips of each other. And since we know that substituents prefer to be in equatorial positions as steric strain is diminished, we can conclude that the ring with the 2 chlorines in the equatorial positions are lowest in energy, while the conformation with the 2 chlorines in the axial positions are higher in energy.
These 2 conformers are identical because after a chair flip, they are the same. Additionally, they have the same absolute configuration prior to a flip. We know they are not enantiomers because they are not mirror images. And we know they are not diastereomers because our 2 molecules have all the same absolute configurations.
Next, we will discuss the placements of the chlorines in our lowest energy conformation. These 2 chlorines are in the equatorial position, and this one is in the axial position. These 2 are cis relative to each other. However, these 2, relative to that one, are trans.
Now we have made the 1s, 2r, 4r trimethylcyclohexane. If we look at the 1,2,4-trimethylcyclohexane and compare it to the 1,2,4-trichlorocyclohexane, we can conclude that the 1,2,4-trichlorocyclohexane is the highest energy conformation because it has bigger substituents, therefore having more steric strain. The 1,2,4-trimethylcyclohexane has the lowest energy conformation because it has smaller substituents and therefore having less steric strain.
Next, we'll discuss mesocompounds. A mesocompound is a single molecule that is achiral by virtue of a plane of symmetry through the molecule. Since neither 1,2,4-trichlorocyclohexane or 1,2,4-trimethylcyclohexane have a plane of symmetry, neither of the molecules are mesocompounds. No plane of symmetry, no plane of symmetry, and no plane of symmetry. No plane of symmetry, no plane of symmetry, and no plane of symmetry.
Adios, chemistry gang.